There you go. You got it. Okay. So the first thing we want to look at is on this horizontal asymptote, right? And again, by the horizontal asymptote test, what we want to do is we see, oh, the highest power in the numerator, which is the degree, is the same as the highest power in the denominator, which is the degree, right? So since they're equal to each other, we look at now their leading coefficients. I don't have a leading coefficient here, so it's a 1, right? So my horizontal asymptote is just the ratio of my leading coefficient over my leading coefficient. Y equals 2 over 1, which is just equal to 2. That easy. Vertical asymptote. Vertical asymptote is going back to chapter 1. What do we do? Oh, we set the denominator equal to 0. So we have x squared plus 2x minus 3 equals 0. Oh, looks like a nice little factoring problem. X, let's see, we're going to do minus 1 times x plus 3. Let's see, does that work? Looks good to me, right? So therefore, I have an x vertical at x equals 1 and x equals negative 3. Now, so I found the asymptotes. I found the asymptotes. Now that 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 I found the asymptotes, I can now move to the x-intercept. The x-intercept, remember we talked about, guys, was basically you're going to get the same thing. You're always going to multiply the denominator on both sides. So just set the numerator equal to 0. I could divide by 2 and take the square root. But I think at this point in this game, you guys know that x is going to equal 0. For the y-intercept, I could plug 0 in for x and solve for y. But what I notice, it's going to be constant over constant. I don't have a constant here, so I can use 0. So what happens when I have 0 equals over 3? Which is just equal to 0. Okay? So now let's go and take a look at the graph and confirm our